Welcome back to Further Solutions Academy. On this video, I'll be working on a vector space. Don't forget to share, subscribe. If you have not subscribed before, kindly subscribe at this point. We have all what you need from mathematics for you. You'll be fine with it. I think this is linear algebra 1, which we have done a lot of videos on metrics, which you have no problem with metrics. All the method, you are good to go. But this time around, I'm working on, we have done vector, which is the first outline. We are now on vector space. The outline of this video, I'll be working on vector space itself. I'll be working on a polynomial space, linear combination, and several examples. By the end of this video, you will understand this part of mathematics very well. I really want to appreciate my students. I think they are doing well. I'm talking about Samuel, Justice, and Joyce, and so on. You should continue using the video. You'll be fine at last. Okay. But this course is a year 2 course. Anyway, now let's try to work on it and let's see what we will arrive at. Now, when we talk about vector space, when you get word vector space, now it means, okay, that is what vector space is all about. A vector space over R consists of a set V along with what? Operation plus and multiplication. That is what we are talking about on vector space. Or at this point, you'll be hearing the word field. When you hear the word field, don't be carried away. The first time we hear the word field, it's just like it's a place that contains a container that contains all the what? Mathematical operation, like plus, minus, multiplication, division, equal to, and so on. They are all field. Do you get me right? That is what you need about that. Don't forget, don't be carried away when you see a word field, because it's a very common part of my language, and a very common language on mathematics that you'll be hearing every time. And we have some condition. Let's talk about the condition of vector space. Condition. Now, when we talk about the condition, the first one you need to know is that when you add up two vectors together, don't forget, make sure you watch the first video. When you add vector u plus v, it will also belongs to what? V. It means the set of vector under the addition, that is to say this equals to this, that is, you are to have it. When you add two vectors together, for instance, a equals to, okay, u equals to 2i plus 5j, and v equals to 3i plus j. Now, if I should have u plus v, it will be equals to what? 3i plus 6j. Can you see? You are still, this particular one, this also what? A vector. It means u plus v also belongs to the vector. It's also under vector. That is, take note of that very well. Take note of that very well. Just give example. Another thing you need to understand here is that when you, vector commutates. Now, when you talk about commutative, or commutation, whatever you call it, commutative, it means u plus v can also be equals to v plus u. U plus v, it means position does not matter. Now, the same thing, likewise multiplication, when I have a times a v, it also is the same thing as what? V a. Think of that. And also, it associates. Now, vector addition, how do I spell associate? So, associative. Now, when you talk about associativity, it means, I'm talking about 3, a plus o, u plus v plus w can also be equals to u plus v plus w. That is associativity. That is what is called associativity. Can you see? Can you see that is what, if you operate on this and also operate on this, you will surely have the same thing. That is called associativity. The next thing I need to understand, is what is called zero is also a member of what? Vector. Do you know that if I have a vector, 0 plus a vector is also belongs to what? A vector of the same vector. Now, it means I can say that what? 2i plus 3j plus, this can be plus 0 plus 0 plus 0. Think of this. This is a, okay, plus 0. This can be I, can be j. Can you see I will still have my what? It's also the same thing as what? My vector, which is going to be my v, which is 2i plus 3j. Take note of that very, very well. Another thing you need to understand that is that, number 5, you need to understand that, now, when I had v belongs to big V, and as a what? Addition inverse, as addition inverse, like if I have, this can be inverse. What will make this one to be inverse? If I have 2i plus 3j now minus 2i plus 3j, can you see it will land me at what? It will be equal to 0. Now, because it is equal to 0, this is the inverse of the given vector. For instance, if I have v minus v, which is equal to what? Is 0. That is what I mean by what? Addition inverse. This is a vector, this is a vector. When you had the two vectors, the same vector together, you subtract the two vectors from themselves, become what? Is 0. Is 0 vector. And don't forget, that is called a plus minus. This is how to present inverse. It means additive inverse is the negative of that element, or negative of that given vector. Take note of that. Okay, which it will surely give me 0. That's what I'm trying to explain, emphasize on that part. And another thing you need to understand is that now, if I have a dot b, which is a multiplied by, this is a scalar. Don't forget that a belongs to what? K, and v belongs to what? Of v. This belongs to v, which is a vector, a scalar. Just note that it will surely give me what? A v. It's also give me a v, which is going to be what I'm trying to explain there. That is what it's only with what? A v that also belongs to what? V. When I have a scalar multiplied by a vector, it will surely give me what? A vector. For instance, 2 bracket of 2i plus what? Plus 3j. It will surely give me what? 4i plus 6j, which is also a vector. This is a vector. And you see, I'm not yet on the vector. I think very soon, on the next video, I'll be explaining what is called spanning. Span of a vector. You need to understand that part very well. It means we call it a generator. It will generate another vector. Okay, I think it's getting better. Can't you see? Let me call this place 6. Another thing you need to understand is that we have what is called distributive multiplication, distributive. Now, over scalar, which is if I have a plus v. Okay, let me use v. I've been using u and v, and I have what? I have a. I have a, which it will also be the same thing as what? A v plus a w. AU plus AW. Now, don't forget, my A belongs to scalar and my UV belongs to vector. Please take note of that. This statement is as important as anything when you are solving any question. Please learn to define. This is called definition of what I'm doing. And we have what is called left derivative and right. And also we have A dot B of V can also be equals to what? AB, V. Oh, AB are in scalar and V are in what? Vector. Take note of that. Take note of that. I'm just trying to explain that this is going to be 7, this is going to be 8, and the last part of it, we have this called, if I have 9, I have 1 of it to be equals to what? It means 1 multiplied by a vector, it also becomes a what? If the v belongs to what? Of this. That is what you need to know about that. I think by now you should understand what is called vector space. Now let me try to explain polynomial space. Polynomial space. Now, polynomial space. Now, let's talk about polynomial space. Polynomial space is just like, okay, now, polynomial. The polynomial space, which is P of t, if, let's P of t, sorry, this is a statement error. Let P of t denote the what? The set of all polynomial of the what am I writing? Of P of t. Of P of t, sorry about that. Now, P of t is equals to what? This is how polynomial normally look like. This is the nature of polynomial. U of n, which is naught, it means t of naught. U1, T1, U2, U2, UN, Tn, when you are having, you know what is called polynomial now. F of s, mapping, linear mapping, all these things. You are talking about what? Polynomial. Now, there are some conditions. Let me talk about the condition of it. Condition. Now, let's talk about the condition. The first one is that vector addition. My vector addition I'm talking about is P of t plus Q of t. It will be equals to what? P of t. Now, P of t, it means a polynomial plus another given polynomial. It will surely give us another polynomial. That is condition number 1. Condition 2, if I have scalar multiplication. Now, my scalar multiplication, it means if I have my k of P of t, will surely be equals to, I hope I'm saying the right thing, yes. It also belongs to what? It also belongs to P of t. Take note of that. It means if I have a polynomial and in open bracket, or I include like R2i plus 5j of bracket of what? Okay, let me just put t and t. This one can be t squared. Now, which is bracket of what? My scalar can be what? 3. Now, this can be equals to what? 6t plus 5t squared. This is a polynomial. Can you see this is a polynomial? That's what you are trying to do there. And also, if I have a metric space, you know what's called metric space? Matrix space. You know what is called matrix space, which we have done number 4. We talk about a function space. Now, function space is also, we call it, that's what we are doing on linear mapping, which I'm talking about. If I have f plus g of x, or of t rather, we are using t, we can be talking about what? F of t plus g of what? Of t. Don't forget that is what. And if also I have k of what? Of f of t, which is, I have it in this form. This also the same thing as k f of x, which I'm saying that what? My x belongs to what? Oh, let me be. I'm having t. I'm having t. Sorry, I'm used to say x. My t belongs to what? P of t. That is what I'm trying to talk about. That is what I'm talking about. Now, before I end this, let me use this opportunity to talk about linear combination. Linear combination. Okay, now look at what linear combination is talking about. Let V be a vector space over a field. I've explained field just like a container. that contains all the mathematical operation: plus, minus, times, division, equal to, inequality, greater, not equals to, and so on and so forth. Okay, of field K. A vector V in a linear combination, it means when you are having something like this, belongs to V. If there exists, this is called there exists in mathematics. We have there exists, we have such that, we have belongs to. I think those things look the same. Go and find out. There is a scalar, this, in K, such that this equals to, this is called the linear combination. That is called linear combination. It means if I have a what? 2x plus 5j, 5x squared, or let me just use 5f, 5y plus n. This is a linear combination equals to what? Now, this is equals to a v. This is called linear combination. Take note of that very well. This is called linear combination. Number one, this can be A, this can be what? V. Are you going to say now, depend on what I declare on the given problem. I think you can understand what is called linear combination now. By now, let me try to explain with example linear combination so that for better understanding. For better understanding. Now, I have some problem here, which I need to show one or two examples. I have to show an example. Now, look at this problem. Okay, look at these two questions as an example. Suppose V equals to 3, 7 minus 4 in R3, a linear combination of the vector this. Okay. Now, that is it. I want to try to generate linear combination there. This also the same thing as this, and let me try to solve this one. Let's try. Now, if I'm to solve this something like this, it's very simple. How do I get my linear combination? Just note that let x, y, z belongs to what? K. Now, this my K, we also call it coordinates. Please. This is also known as coordinates. It means I will be having x u1 plus y u2 plus z u3 equals to what? V. Equals to V. Now, with this is called linear combination. Linear combination. Please take note of that. Linear combination. Now, how will I make it real? X, what is my u1? My u1 is 1, 2, 3, and plus y. My u2 is 2, 3, 7 plus z. My z is my u3 is 7 minus 4. Can be equals to 3, 7, and minus 4. Can you see? Now, by so doing that, I'll be having x plus 2y plus 3z equals to 3, equation 1. And I have 2x plus 3y plus 7z equals to 7. Is it 7? Yes, 7z equals to 7. And I have 3x plus 7y plus minus 4z equals to minus 4. Equation 2, equation 3. Now, can you see how to solve? Now, if you are asked to find the what? The coordinates. Now, if you are asked to find the coordinates, you can now run to any of your methods. You can run to Cramer's rule, can run to row reduction, anyone you feel like, which you'll be fine with, you can run to it. That is the linear combination. Now, if I'm to solve the second one, I think you can be achieved by running to matrix here. If I want to do matrix, I think augmented and 2, 3, 7 augmented 7, and augment okay, 7, 7 minus 4, and augment minus 4. That is what, by so doing that, I can find my what? X, Y, Z, which you should know that. Now, this also the same way, I will I can say that my x1, x2, x3 belongs to what? That is that. And these are vector. u1, u2 are vector. u1, u2, u3 belongs to what? Vector. Now, it means I can say that my linear combination will now be equals to x1, 1, minus 3, 2, plus x2, we have 2, minus 4, minus 1, plus x3, we have 1, minus 5, 7, equals to what is my v? My v is 2, 5, 3. Now, by now, everybody should understand what is called linear combination, which is x1 plus x2, 2, plus x3 equals to 2, equation 1, and minus 3x1 plus minus 4x2 minus 5x3 equals to what? 5, equation 2, and 2s1 minus s2 plus 7s3 equals to 3, equation 3. Now, this and this are called linear combination. Can you see? That is called linear combination, and I think I'll explain that part very well. Okay, there are some problems also that I need to show you. There are some problems that I need to show you. Look at this problem. Okay, look at this problem. It's another way. This is express the polynomial v equals to this in p of t as a linear combination of the polynomial p1, p2, p3. Solution to this problem is very simple. What you just need to do now is that how do I express this as a linear combination? Don't forget what I told you, that I will declare this x, y, z belongs to what? Belongs to K, which is a field, and P1, P2, P3 belongs to what? P of t, which is a polynomial. And what I need to do now is that I will declare this, and I have x P1 plus y P2 plus z P3 equals to what? What will be equals to V? Now, what is my x? My x, we have what? My P1 is equals to t squared minus 2t plus 5 plus what is my y? My y is equals to p 2t 3t plus what is my z? My p3 is equals to 2 minus plus 1. What is my equals to what? My v will be equals to, let me not, sorry, I don't need to stress myself because of God, we have a very big problem. T squared plus 4t minus 3. That is what we need to do. How do I continue? I'll be having t squared of x plus minus, I'm just opening bracket of x plus 5 of x plus y 2 t squared plus minus 3ty plus c z equals to what? T squared 4t3. Now, what I just need to do, I will make sure the one that has t, I will compare the coefficient, which I have st squared plus 2yt squared will be equals to t squared, implies x plus 2y equals to 1, equation 1. Now, I will move on to the next one that has t minus 2tx minus 3ty plus zt. It will be equals to 4t. It implies minus 2x minus 3zy plus z equals to what? 4, equation 2. Now, I'll move on by having this also. I have 5x minus plus z equals to minus 3, equation 3. Now, by so doing that, I can now continue by having my what? If I want to derive my syz, you know what to do. You run to your matrix or linear combination, by your simultaneous equation, you will get those things very well. Can you see how simple linear combination is? It's very, very simple. Now, before I end this part, let me try to explain some things that are very, very important. I want to explain what is called norm. Norm. When you hear the word norm, it's something as we are talking about. Okay, before I explain norm, let me try to explain something which is very common. I've seen it before somewhere in the past question. Okay, look at this very common question. I think it's a very simple one, but I've met it somewhere in the past question, which I need to explain it somewhere. Okay, somehow. If you have something like this, it's very, very simple. What you just need to do is that, for instance, my E1 now will be equals to 9u minus 12v plus 5u plus 7v. Now, this and this will give given 14u, and this would be given, I have 14, I have, is it 14? I think, I'm not making any mistake. Okay. Oh, this can never be 12. Sorry about that. This should be 18. Thank you. Now, here will be giving me 18, and here and this will be giving me that, and that will give me what is called root 3. I hope I'm not making any mistake. 7. We have 3u. Okay, sorry, I make mistake. Sorry about that. Sorry, make mistake. I was looking at something there. Now, u1 will be this times this. It will give me 9u minus this times this. It will give me this times this. It will give me 12v minus 5u plus 7v. Now, this, let me collect like time. It means I have u plus 5u plus 5u, okay, and I have minus 12v plus 7v. Now, this and this, it will give me 14, which is going to be 14u. This and this, it will give me minus, we have 3 and 5, we have 5. That is my answer. That is my answer. Now, okay, that is my answer. The next one will be equals to, I have my u2, which you can do the u2 by yourself by having 3u, 9, 12. Okay, that is just it. Now, 3u minus this times this, it will be 18u plus this times it will be 30v plus 7v. Now, which I have this and this, it will give me minus 15u, and this will give me 37v. Now my u3, which is I'll be having 2uv plus 6u plus 12v. Note that uv do not exist. Please take note of that. Does not exist. Now look at this problem. You are given u equals to this, v equals to this. So find k so that u and v are orthogonal. I've told you that time that when you hear a word orthogonal, it means their dots u dot v will be equals to 0. Now u 2, 3, 4, 6k and 2 equals to 0. Now this times this, it means if times this is to be 6 plus this times this, you have what? Oh, I'm not making any mistake. We have 2k plus and minus 8, minus 8, 24, and this times this plus 8 equals to 0. This, it will give me 2k minus 10 equals to 0. 2k equals to what? 10. My k will be equals to 5. It means my k to be orthogonal u dot v will be equals to 0, which I have 1, 2, 3, 4 dot what? 6, 5 minus 8. When you do the dot of these two, to surely be equals to 0. That is what we are trying to say. I think I've covered everything now. But before I end this video, let me try to explain what is called length. Length of a vector or norm of a vector. You can also call it norm or you call it length of a vector. Oh. Now, when we talk about length of a vector or norms of a vector, now norms or length of a vector, when you hear a word length or norms of a vector, just put it at the back of your mind that it's related to what? Magnitude of a vector. Now, that is very, very important, which is always noted by what? Something like this. This is called norms. We call it non-negative value. Please take it of that non-negative value. That is what we mean by now. If I have norms of u will be equals to root of u dot u, which it will be equals to root of, I can put root of let me just put u1 squared